Okay, I hope my screen is visible. Can someone confirm if my screen is visible? Okay. Okay, let's get it started. So we need to do a small recap, and I think I should flame you more about this upcasting concept. So yesterday I have just we have discussed a lot of theory. So this upcasting, okay, when I say upcasting, we upcasting is one of the categories under user-defined data type, typecast, right? So you can call it as class level typecasting. Okay. So actually, usually there are two types of typecasting in Java. We know what are they? We have primitive data type typecasting and user-defined data type typecasting. Okay, I don't think we need much explanation about this primitive data type typecasting. We have discussed a lot of things on this topic, right? And we have implicit typecasting as well as explicit typecasting. So this is going to deal with the primitive data types. We have seen this, right? Integer, byte, short, float, double, things like that, right? So our discussion is on top of user-defined data type typecasting. Okay, and again it is categorized into two types. One is upcasting and the second one is downcasting. Okay, upcasting it is a type of typecasting in which a child object is typecasted to the parent class object by using the typecast operator. Lot of theory, we are seeing a lot of theory, right? And we have seen one practical example. I have taken a mobile class and I have taken iPhone class. The people who have missed yesterday's class as to repeat this video, as to see this video, so that the topic that I am going to discuss now will be making more sense. Okay, we will continue with another example on top of upcasting to understand this better. Okay, then the concept of downcasting concept is going to be kind of 20 minutes discussion. That's it. You need to get much understanding, much awareness about upcasting topic. Okay, shall we proceed? Everyone type yes in the chat box. Everyone type yes in the chat box. Yes. Okay, I want your interaction. I want to ensure that you people are interactive. That's the reason why I'm asking you to type yes. Right. So today let us take another example, guys. Okay. So let me keep this main method just like this. So okay. Now this time I'm going to take a class. The name of the class is animal class. Okay. Animal class. Every animal is going to make some noise. Yes or no? Every animal is going to make some noise. Okay. A typical animal, if you don't know, if I talk specifically about an animal, there are many animals, right? So I just want to say blah blah blah. So we are not sure which animal you are talking about. So there is a method inside the animal class. The name of the method is make noise method. Okay. So when you invoke this method, it is going to print something like blah blah blah. Don't think about the logic. It is not a logical thing that we are discussing. We are discussing about the control flow. We want to check whether which make noise method is going to be called, which method is getting called. Okay, so if this method is getting called, this will be displayed on the console, so that yes, we will be aware that this method is called. Okay, don't think about the internal logic. Okay, I am taking another class, and this time the name of the class is dog class. Okay, dog is extending to animal, right? Dog is extending to animal, and dog is going to make noise. Yes or no? Dog is going to make some noise. Sometimes that noise can be a nuisance to us, right? Wow, right? Dog noise. And again, let us take I do not want to add this, keep this method. Let me remove this method. Okay, let me take another class to make more sense about this upcasting. Okay, this time let it be cat class. Okay, cat is going to make some noise. Yes or no? It is going to do what? Going to say meow meow. Right? So far things are good. Okay. So let's do a small understanding about this program. I have three classes. One is animal class, second one is dog class, third one is what? The cat class. Okay, this dog class is extending to animal, and cat class is also extending to animal. Okay, each and every class, okay, each and every class has some method. The name of the method is say make noise, but when you invoke this make noise, you get blah blah blah. When dog is making noise, when you invoke the make noise method of dog class, it is going to say oh oh oh. When you invoke the make noise method of the cat class, it is going to say meow meow. Okay, so what kind of inheritance is this? What kind of inheritance we are talking about here? Can anyone guess about the type of inheritance that I am discussing now? Any idea about this inheritance? Okay, we have an animal, we have dog, we have cat. Okay, both are extending to animal. Don't you think that this is an hierarchical inheritance? One parent, two children, hierarchical inheritance. Okay, you should keep these things in mind. So inheritance, when I asked you about the type of inheritance that this program is talking about, of course the type of the inheritance is hierarchical. Why hierarchical? We have one parent class and two child class, dog class and cat class. Do you agree with me or not? Yes or no? Good, Chaitanya. What about others? Only Chaitanya is responding. I want response from everyone. Do you agree with Chaitanya? Type yes if you agree with Chaitanya. Everyone. Okay, Chaitanya is typing yes for Chaitanya itself. Okay, so see, now the discussion, the topic of discussion is upcasting. Okay, I'm taking a method class, I'm taking a class test. Okay, inside the class test, I'm taking a method public static void main method. Okay, we need a main method to perform the execution. Yes or no? Okay, this main method as string array aux. Okay, I will be writing something here. I will be creating some objects, and we will see how upcasting is going to help us. In what way the upcasting topic is going to help us. In what way we can get benefits from the concept of upcasting in Java. Keep in mind upcasting. So what are the benefits that we are going to see from this upcasting? Right? So what is an upcasting? First of all, yesterday I have said upcasting like, what is an upcasting? Go here, right? And go to our theory. It is a type of typecasting in which child object is typecasted to the parent class object by using typecast operator. What does it really mean? What does it really mean? Okay, I am saying, okay, just keep in mind, let me take one more method here. Okay, I do not want to, I'm not increasing the complexity. I am adding a few more methods to understand this better. Okay, I will ensure that you are not getting any confusion. Okay, then the method name is here void I'm getting void category. Void category. Okay, one additional method I'm taking it here. The name of the additional method is void category. Okay, inside this category I'm saying both wild and domestic. Okay, now in the dog class I am taking the category. Instead of category I am taking another specific method here. In the dog class I am taking void foot. Okay, void dog foot. Okay, so let us say dog foot. Okay, and I am taking another method here void cat foot. Okay, cat foot. Okay, so let us brief this once again. I have an animal class, I have a dog class, I have a cat class. I have totally 4 classes including the test class. I have totally 4 classes including the test class. Okay, now we will understand about this upcasting. What are the advantages that we are going to get from this upcasting? Okay, now what I am trying to do it here. So when I create an object, I can create object in many ways. Yes or no? For example, if you are considering these two classes, animal class and the dog class. If I ever had to consider these two classes, I can create object like animal a equal to new animal. Natural. When I do the object creation in this way, so this is what parent to parent. This is natural. And second one, dog d equal to new dog. Right? This is what child to child. Okay, these two things are natural. You can create object for the parent class and you can keep the reference of the parent class. Natural. You can create object for the child class and you can keep the reference of the child class. This is also natural. But what is not natural? What is not natural? Okay, when you create an object for the child class, new object, a new dog. Okay, this dog is what? This dog is child of animal class. Yes or no? This dog is child of animal class. Dog is child, animal is parent. Right? You create an object for the child class and you typecast it to the parent class type. You typecast it to what? You typecast to it parent class type and you assign it to what? You assign it to the parent class reference. Okay, object is being created for the child class. You do the typecasting. You're typecasting it by using the typecast operator by using the parent class type, and you assigning it to the parent class reference variable. This part is talking about upcasting. Right? So upcasting is okay. Now upcasting no, is okay. What are the benefits that we are going to get by doing this? And one more thing, this animal, okay, this cast operator is an optional thing. You can use this or you can remove this, no issues. If you are going to remove this, internally compiler is going to consider this. That's why it is called as what? Implicit typecasting. Implicitly, compiler is going to do the typecasting for you. Okay, when I say compiler is going to do the typecasting for you, what does it mean? Compiler is going to use this typecast operator and add this animal reference. Okay, even though when you just do this, okay, this is called upcasting. It is also called as implicit typecasting. Implicit typecasting. Why implicit typecasting? You do not have to worry about the typecasting operator. This typecasting operator, this animal will be added by the what? Compiler. That's why it is also called as implicit. This will be taken care implicitly. Right? So I can keep this, I can remove this. Okay, let us learn this by keeping this. Okay, even if you remove this, no issues. It is going to work. Okay, so what we have achieved because of this, when we have achieved a concept of upcasting. Now go back to the theory. Okay, the theory says, according to our theory, a child object is typecasted to the parent class object. Okay, we have achieved that. Yes or no? The child object, dog is the child object, is typecasted to the what? Parent class object. And you have assigned by using the typecast operator, and this part is assigned to the parent class reference variable. Animal. Okay, so far good. We understood what is upcasting and we have also understood what is implicit typecasting. Okay, what are the advantages that we have here? We will see that. Okay, let me copy this code. Let me open the paint screen. Okay, people who missed extradite class, listen to this. This is going to be this is our code, right? Let me remove this part. Yes, it's good. Okay, we have animal class and we also have something. Okay, this is our code. Okay, so let us remove this. Let us not consider this part for now. because we are dealing only with two classes. Okay, I'm removing this and I'm pasting this. Okay, look at this code. We have animal class. Okay, this is one class, and this is another class. This is another class. Very simple to identify, isn't it? Two classes we have, and there is another class, main class. Okay, here we are performing something, a concept of typecasting. Okay, now you see the main thread will come into the picture. Okay, main thread will get access to the main method. Yes or no? What's the first line inside the main method? Animal a equal to new animal. For the new keyword, an object gets created. Yes or no? For every new keyword, an object is going to get created. Okay, this object, new dog. So no, new dog. Go to the dog class and see how many methods are there here. Go to the dog class and see how many methods are there. Don't you think that there are two methods? One is make noise method. Second one is what? Dog food method. Yes or no? Right? So this is going to be what? Make noise. Okay, make noise method we have. Second one is what? Dog food method. Dog food method. Right? Two methods are there. Okay, yes. Then what we are doing, this object, okay, we are typecasting this object. We are doing what? We are typecasting. Why it is dancing? Okay, we are typecasting this object to which type? To animal type. To which type? To animal type. We are saying, of course, the object, this object is belongs to the dog class, but I want to do the typecasting. I want to convert this. I want to convert this object to what type? I want to do the conversion to what type? Animal type. Right? This has been converted to animal type. But the moment you do this conversion, the moment you are doing this conversion, the moment you want to do this conversion, okay, this is dog. Okay, dog is getting converted to animal type, internal things. Okay, first just imagine how many methods are there inside the animal object. How many methods are there inside animal object? Let us take this as this is animal object. If we ever have to create an object for the animal class, of course there will be two methods. Okay, make noise and category. Don't you think that? Make noise. Let me write it in red. Okay. Focus here. Make noise method is there. And we have category. We have what? Two methods. Make noise method, category method. Inside which class? Animal class. Okay. So you are saying that I have created an object for the dog class. Okay, this part is an object creation for the dog class. Try to understand. This particular part is object creation for the dog class. Okay, but after creating the object, you are doing the typecasting. You're doing the typecasting and you're converting it to what? Animal class. You're converting it to what? Animal class. When you do this conversion, what exactly will internally happen? You know, what exactly will internally happen? It will try to do the comparison. Is there any common methods between these two objects? This is animal object. This is converted dog object. Dog is converted to animal. Typecasted dog object. Is there any common methods? Of course, there is a common method. This is a common method. This is the common method. This method will not be touched. This method will not be touched. Is there any different method? Okay. What is the method that is different in nature? These two are common methods, so no issues. This common method will be here. Okay. So is there any method that is different? This method is a different one. Yes or no? Category method is a different method and dog food method is a different method. Right? So because of this conversion, common methods will not be touched, but the uncommon methods in the animal object, animal classes object will be replaced. Will be what? Will be placed here and this will be removed. Again, I'm repeating. Because of this typecasting, the common method will not be touched. This will be not touched. Why this will not be touched? Because don't you think that make noise method is same as make noise? Both are make noise method. Method name is same. Overriding concept. Method name is same. It will not touch this method. Okay, but there is an uncommon method. Let me go back here. Common method will not be touched. Okay, it will remain here. Okay, the uncommon method is what? The category method is not a common method. This category method is specific to animal class. Specific to animal class. It is dog is converted to animal class. Inside the animal class, category method is specific to animal class. So this will try to what? This will try to occupy here. This will try to occupy here because it is specific to animal class, right? Since animal class, since it is typecasted to animal class, the non-specific method in the dog class will not be removed. Right now, from this reference, what is the reference variable here? Reference variable is A. Reference variable is what? It is holding the reference variable A. Right? By using this reference variable A, I can get access to make noise. I can get access to category, but I cannot get access to dog food. Understand? This is the advantage. It doesn't look like an advantage now. It looks like a confusion now. But in future, there are some topics where you will find this upcasting topic as an advantageous one. Where is the proof? By using this A reference variable, I can able to call make noise and I can able to call category. If I call make noise, this make noise of dog will be called because it is untouched. It is untouched. Or it is overridden. It is going to be there because both are common. Okay, this animal class object will not replace this because it is already there during the conversion, but the category method is not there here. So this category method will come and sit here, and the dog food method will not be available for this object, for this upcasted object. Where is the proof? If I try to run this, okay, let me save this file, save as, right now. And I am supposed to save this as test.java. It's not test.java. Right? So let me run this. If I run this code, I don't think I will get any error. Output is going to be empty. Java C space test.java. Space test. Output is empty because I'm not calling any methods. Okay, I have just created an object. Now I want to call methods. I want to call a dot what? A dot make noise. Which make noise will be called? A dot make noise. Make noise, NOIC. Right? A dot make noise, and I want to do call what? A dot category. I can call only two methods because of this. I can able to call only two methods because internally after the typecasting, this is what happened. I will give you the another example for the better understanding. For now, the common methods will not be touched. The uncommon methods, okay, the method that is not common here, okay, is going to, this method that is already available in the animal class object is going to be placed inside the dog class object because this dog class is a not dog class object anymore. It is a typecasted, it has been typecasted to animal. So that's why this is going to what? Will be available for this particular object. Right? So I can call what? I can call make noise method, I can call category method. Okay, let me run this code. Java C space test.java, Java space both wild and domestic. Why we are getting? Because a dot make noise. Okay, go back to the paint. Okay. We are calling a dot make noise. This make noise method is what? It is a dog class method. It is untouched. It's not yet replaced. Okay, it is untouched. That's why we are calling. Now a dot category. A dot category. A dot category means what? A dot category. Okay, what is the method in the category? What is the instruction in the category? Both wild and domestic. So this is going to get executed. Right? Now if I do what? If I try to do a dot dog food, I will get an error now. Because dog food method is not available in this object, in this typecasted object. Let me repeat it. Dog food method is not available in this typecasted object. Only two methods are available. You can access make noise method, you can access category method. Dog food method is not there, it has been sent out because of this typecasting. If I try to run this, I will not be getting any kind of output now. Okay, instead I will get what? I will get I will get a slab from the compiler. It says dog food of a type animal is not available to us. Let us repeat the same thing. Okay, instead of doing this, now let me introduce this cat class also. Now I want to work with this cat class. Okay, now instead of doing like this, I'm saying cat. Now listen once again, I'm repeating this for a different class. Cat C, sorry, animal A equal to new cat. Okay, animal is parent, cat is child. How can you confirm? Cat is extending animal. Okay, the class that is after extends keyword is parent always. The class that is before extends keyword is a child always. Okay, I'm doing the upcasting. Animal equal to new cat. Okay, internally, since it is an implicit upcasting, this part is going to be what? Like animal. It will be a typecasted to what? Animal class. Even you do this, or if you are not doing this, compiler will take care of this. Okay? So now I want to call. Okay, because of this line, let us see what is happening once again. Okay, for the better understanding, let me copy this. Now focus here. If you are not understanding this, you will understand this now. Okay, focus here. I'm just trying to repeat this once again. Very important topic. Now we are working with cat class. Okay, I do not want this object. Okay. Let me take this space. Right. Okay. Where is it? Okay, now everything is fit here. Let me move this main method. Okay, this is the main method. Okay, now see, by looking at this code, the code is visible now for you. Is it visible or not? Please confirm the code is visible. I have just decreased the font size. Are you able to see this code properly? You want me to increase the font size? Visible. Okay then. See, now let us try to understand this. Okay. See, animal equal to new cat. Okay. Now we are not working with this particular we are not working with this dog class. We are not working with this dog class. Okay. Since it is hierarchical inheritance, since the object is getting created only for the cat and we are assigning it to the animal, so we do not have to worry about this for now. Okay, so it has no significant effect. So we are working with cat class, we are working with animal class. Okay, cat and animal, cat and the animal, because object is created for these two, for the cat, and we are assigning it to the animal. Okay, now try to understand this. So we are dealing with these three classes. Okay, animal equal new cat. Okay, for the new operator, and we have what? We have the cat class. Okay, object is getting created for what? Cat class. Right. So when I say cat class, look into the cat class. How many methods are there? You have make noise method and you have car. I mean, it's a cat food, guys, not car food. Make noise method is there, and cat food method is there. Spelling mistake. Okay. Yes or no? You create an object for the cat. Okay, because of this new cat, and it is going to have all the methods make noise and catch food. But what we are doing after this, what we are actually doing, we are performing the typecasting. So typecasting is happening internally, right? This object is what? Getting typecasted to animal. Getting typecasted to animal. Okay? When you do this typecasting, when you're doing this typecasting to animal, of course the reference variable is what? A. Reference variable is what? A. Sorry, it be small a. Yeah. Reference variable is what? A. Okay. The old object has been typecasted to this animal object, and the reference variable is a. Okay, so what happens? Okay, the methods inside these objects is going to get affected. How, to how extent it is going to get affected? Okay, let me create an object here. Okay, let us, we are converting it to animal, right? If you ever have an animal object as animal classes make noise method again, and category method is there. Okay, make a noise. Okay, and we have what? Category. We have two methods, make noise method and we have category method, right? And this, think about, this is an object for animal. Just for the imagination I am doing this animal. Okay, this is our actual object. Okay, the moment you do this, the moment you approach this upcasting, okay, you are trying to convert the cat to animal. You are trying to convert what? Typecast what? You are trying to do the upcasting from cat to animal. Cat to animal. What happens? This internal method of cat will be affected because of the upcasting. To how extent it is going to get affected? Okay, first it will identify, it will compare, this two objects will be compared. Okay, so this object will be compared with this object. This object will be compared with this object. How, to how extent it is going to get compared? Okay, common methods will not be touched. Okay, what are the common methods between these two objects? These two methods are common. Do you agree? Okay, these two methods are, this is common method, this is this, it will never be touched. What are the uncommon methods? This is category is an uncommon method, cat food is an uncommon method. Okay, uncommon method, talking about uncommon method. Okay, this uncommon method of cat will be removed, will not be considered inside this object. It says you are not fit to be here. Why? Because the object has been typecasted to animal. Uncommon methods will be removed. Okay, and the uncommon method of the animal will be added because of this typecast. This is the only change that is happening. Common method will not be touched. This two will not be touched. This two is going to remain the same. Right? What is an additional step that has been added just now? Uncommon method of the cat object is removed and uncommon method of the animal object is added. Why? Typecasting. In this way, can I conclude that this A object has access to make noise method and also access to the category method? When I target make noise method, when I target A dot make noise, okay, the make noise of cat will be executed. But when I target A dot category, right, the category method of animal will be executed. Okay. But when I target A dot cat food, I'm sorry, when I target A dot cat food, we get compilation error. Compiler is going to slap. Back to back slap you will get. Okay, compiler error. This is not possible because it is out of the scope. Okay, so when I do this, I have an option to get access to few methods. Okay, common method make noise of cat, this is of cat type. Category is of what? Animal type. Okay, common type is what? We will get none of this one. Okay, when I invoke cat method, so meow will get. right? And when I invoke category, I will get this, but I do not have access to what? This. I do not have access to the cat food method. I don't have access to this. Okay. So what is the point of what kind of restriction is this? Can I conclude that with the help of upcasting, okay, I will be able to get access to the overridden method. Both methods are same in the parent class and the child class. If I have same methods, they are called as what? The methods that are overridden. Okay, the specific method of the parent class will have access. We can access to the specific method of the parent class, but not to the specific method of the child class. Okay, let me run this. Okay, now if I do a dot, what is it? A dot, a new cat, right? So hook the cat. I can call a dot make noise, right? And I can also call a dot category. Both are valid, right? Let me run this code. So I got meow meow, both wild and domestic. Okay, this method is of what? Cat method, I mean cat class method is getting executed. Animal class method is getting executed. Animal class method is getting executed. Why this cat class method is getting executed? Because this make noise method is also common to animal class. In the animal class also you have make noise method. In the cat class also you have common methods. Both are common. Preference will be given to what? Child class method. That's why meow meow me got, right? And category. Category means always animal, specific to animal. Okay. Category. Okay. Then can I get access to this method? Cat food. Let me write it as cat. Okay. Can I get access to this method? A dot cat food. No, I cannot get access. Why I cannot get access? It is not part of the memory anymore. Cat food has been removed. You get what? Compilation error. Okay. You are giving some restrictions. Okay. By this, can I conclude that you are restricting the non-common methods? You are restricting the non-common methods from the child class, but not to the parent class. Parent class non-common methods are getting, you are able to get access, but the common methods from the child class you are able to get access. This restriction is placed for this method. You cannot access this. Can't be accessed. So what you get? You will get a slab from the compiler. Sorry. Can't be accessed. Where is the proof? Let me run this. See, we are getting under. Cannot find the symbol. Why cannot find the symbol you are getting? You are saying a dot cat food. Go to the object. Are you able to see anything like a dot cat food inside this object? Nothing is there. Huh? It is already removed. Scope is not available. Right? Big confusion, isn't it? Yes, no? A great confusion, right? Come on, are we good so far? Everyone are able to understand what is an upcasting? Okay, this significant advantages of upcasting will be, will be understood. What I mean to say, especially in the collection topics, and in the polymorphism, right? Okay, and see what are the things that I can do here. Okay, see. Now I am taking a method. See guys, what is the specialty about this method? Static void, and let us keep the name of the method as noise. Okay, static void noise, right? It is going to we are going to pass something like animal type. Okay, so don't get any confusion. I have a main method. I have also what? I have also a method, a static method. Okay, the name of the static method is something like this. Okay, now what I'm trying to fetch, type dot make noise. Now you see, I want to create object for a and animal obj equal to new dog. Now see the beauty of this concept. Animal obj equal to new dog, I am saying, right? And I want to call this method noise dot, sorry, noise obj. Very simple. There is a static method. Okay, this static method has some logic internally. Okay, so static method is accepting a parameter here. What kind of parameter is accepting? It is accepting an animal type object parameter, animal type object. Okay, it is going to collect this, and it is by using this type we are going to call make noise method. Right now, which object is created? New dog object is created. If I run this code, okay, because of this upcasting codes, because of this static concept, it is going to say whoa whoa whoa, because we are passing dog object, right? If I want to pass cat object, right? Only one small change. It's going to call meow meow, right? I have that control. Okay, in the runtime I can pass something in such a way that the respective common method will be called. That is an advantage. Let me change it to dog. Okay, I should get what? Wow wow wow. I don't think that what is this wow 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 I am shouting. This is just for our understanding. We are getting wow wow wow. Okay, why wow wow we are getting? We are passing animal object. I mean dog object. Okay, dog object to animal. Okay, and we are what? We are passing this object reference to a method called noise method. Okay, this is going to invoke this method, noise method. Okay, and we are passing what? We are passing object. It is like we are passing dog here. We are passing a dog. Okay, how dog is going to shout wow wow wow. Okay, if I pass cat instead of dog, if I pass cat, how the cat is going to shout meow meow. I have that control, runtime control. I have that meow meow. Okay, I can also pass instead of dog. I can also directly pass animal. If I pass directly animal here, okay, what I will get here? Blah blah blah. Yes, no? Very specific. Blah blah blah. So in the runtime, with the help of upcasting concept, you know, I have the control to call the respective common method of this particular class. Because try to understand, we have three methods. We have make noise method common to animal, make noise method, right, in the dog class, make noise method in the cat class. By using this upcasting concept, okay, by creating an object for the specific class. If I create object for the dog class, the dog class method is going to be called. I have that control. Okay, I should get what? Whoa, 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 I should get. Okay, if I create object for the class and assign it to the parent, okay, cat is going to shout like what? Meow, meow. What is it? Okay. Meow, meow. If I do not want to pass both the things, if I just want to stick to the, stick to the normal casting without doing any kind of upcasting, the actual method is going to be called. Okay, what is the actual method? Blah blah blah. Okay, don't you think that we have a control over the logic just by changing this object reference? Just by changing this object reference, don't you really think that we have a control here? Right? So try to focus here. Try to identify common methods. This is a common method, and this is a common method, and this is a common method. Right? With the help of upcasting, you create a relationship from parent to child. Okay, the child class common method will be overridden, and that will be called. In future, I can also call something like camel class. right? I need to create a class for the camel, and camel is going to shout in a different way. Tiger class, it is going to do what? Grr, grr, something like that, a kind of sound. So I have an option. Okay, now only one line I am able to make changes in the runtime. I can do the call. This is an advantage of what? Upcasting. Right? Let me keep this for you. You practice, you will get this. Do what? You will get this. Are we good? Yes or no? Confusion? Really don't have, you don't have any confusion, really? Should I believe? Confusion will be there. Please try to agree. Try to,